Hey everybody, welcome back to our week 3 of Grad Stats at the University of Cincinnati. I am going to do a brief introduction to the lab you're going to do this week. The first thing I want to point out is that you will only have to do a guided activity. You will not have to do an independent activity this week. And that's for 2 reasons. My first motivation to take that out of the picture this week is that it's a shorter week. We have only 4 days because of Labor Day Monday, and I want you to be able to enjoy this a little bit. The year will be hard, so I didn't want to overload you if you have one last weekday. Second thing, if for those of you that want to put in the time that you would put into the independent activity towards some other learning activity in the context of stats, I will post on the additional materials in the Canvas page a workshop that Danielle Navarro, that Australian statistician that I told you guys about on the second week, she created this workshop recently on ggplot. And I mean, she created a workshop from scratch, like assuming zero knowledge of programming for somebody that has never programmed before. And she has the course set up at RStudio Cloud, so she'll provide information on how to access that in the YouTube sequence that she has. I think there are 6 or 7 short videos. Each one of them is about 15 minutes. So if you wish to dig deeper into ggplot and kind of understand its mechanics better, that would be a great lab to work through. And I want you to have time to do that. Not required. You don't need that to succeed in the class. You're going to get more practice with ggplot throughout the whole semester. So it's just something that is additional that you can do, and I'll post there. And at the end of her workshop, she provides a list of 5 or 6 resources for people that want to get more advanced in data visualization tools. All right, so now about this lab specifically. We're going to do a lab for hands-on exploration of data, okay, to answer the questions that we started with on the first video lecture today. So the questions that we're going to explore is, what is the current life expectancy around the globe? And we will use data from 2000. Didn't change that much from then to now. And by how much did life expectancy change in the past century? We'll compare estimates of life expectancy from the beginning of this century to data from the beginning of the past century. Okay? And here is the packages that you need to load. They're here. They're the Tidyverse and ggplot. And I think that's it. And this is the data set that I will provide you with. And when you look at this data set, by clicking there, we can inspect. You can see that we have data from a large number of countries, and I fetched this data, 260 countries, and I fetched this data set from Gapminder website. Okay, we have data on 2 different variables, life expectancy and fertility rate. We're not going to look into fertility rate at all this time. We're going to focus on the variables related to life expectancy. And this data set is in a wide format. And as I said, looking at the data as is not very easy to understand and try to answer the question that we started with, because it's in its raw form. We actually need to do some data manipulation to get the summaries that we need and the plots that we need to make sense of this data and answer the question, see what story it's telling us about the questions we're asking. Now, it's important to note, and I have that written on the RMD, but I want to speak to you about that this data set is in what we call wide form, and that's a data set where every single row refers to a unique data unit. So in this data set, a data unit is not a person, it is a country. So every line, every row here, every line in this data set refers to a unique country. And because of that, I'm measuring life expectancy in 2 different years, but it's the same variable. I'm measuring the same thing, right? How many years can people expect to live? But it shows up in 2 different columns, even though it is one conceptually, it's measuring the same thing, life expectancy. It's measuring it in 2 different points in time, and then it creates 2 different columns of data. Now, the negative thing about this data set, this organization of the data set, is that the variable year, the year that the observation was made, is not explicitly listed in the data set. So we don't have a column where it says year. And if year is our explanatory variable, like for example, when we say, did life expectancy change over the course of the years, does the passage of time kind of explains changes in life expectancy, it would be nice to have year explicitly in the data set, right? To parse the data in ways that allows those comparisons to be made. So we will start this lab by showing you the process of transforming the data set into a format that we call long format that is better for analyzing data more efficiently, for plotting data more efficiently, for parsing data more efficiently. So when you have your explanatory variable, which is a factor variable, explicit, you can use it to manipulate your data in multiple ways that you will see in the lab. What I want to make super clear is that I don't want you to be overly concerned that you have to learn the details about reorganizing data sets. That's not the focus here, but I do want you to go through the process at least once to let you experience a bit what statisticians sometimes face when they get a very messy data set to begin with, and how there are tools that can make the reorganization, the cleaning up of the data set pretty simple. So that's where the lab starts. And then we move on to, after we do some data cleaning and I introduce you to some tools to do that, we go to the questions themselves. And then you're going to go through the process of summarizing data numerically and also plotting the data so that we can have visuals of that data set. And in the end, we will, in this process, we're going to reason through the meaning of what we're saying. All right? So I'll stop here, let you work on this. It's going to be, everything that you have to do will be listed on the Canvas page as usual. Start by looking at the module page, where I'm going to, as usual, post the videos, post the lab information, the link to the lab, and the process, apart from the fact that you will not have an independent activity, will be the same. One comment I need to make, one of your colleagues experienced an error when knitting that I want to point out, because it may happen to you and it's so easy to fix, but it's hard to know if I never told you that that's the case. I told you before that what tells R that we're beginning to write a piece of code is those 3 little quote marks, and it opens this bracket here, and then it says R, and then you are allowed to make a description of what it is that code is about. If you have 2 code chunks with the same name and you try to knit, it's going to knit and convert your document. An error is going to pop out saying that 2 code chunks have the same name, but it's going to use funky programming jargon that makes it hard to understand that this is what's going on. But once I fix that for your friend that had that problem, the file needed normally. So make sure that when you're copying and pasting code from one box to the other, you just copy and paste the code, just in case there is a name in one of them and that gets replicated, that will introduce that error. All right. So I think this was it in terms of big, like a bug that really stopped somebody. But please continue to write me and write Dalton if you have any questions, concerns. Again, we can get into your assignment in RStudio Cloud and help you out pretty promptly. So don't get stuck and frustrated. Reach out and talk to us. All right. So I'll see you on Wednesday on our live chat for those that can be there. And I'll also post a video for you guys of the live chat that we had last week. All right. Have a great Labor Day and have a great week. Bye-bye.